Hey, what's up, growers? Welcome back to another video. Today, we're diving into one of the most misunderstood and most powerful variables in plant lighting, daily light integral, or DLI. If your plants are underperforming despite dialing in nutrients, environment, and genetics, there's a good chance the problem isn't what you're feeding them, but how much usable light they're actually receiving each day. A lot of growers focus on hours of light or raw ppfd numbers, but those alone don't tell the full story. DLI is what ties everything together. It represents the total amount of photosynthetically active light your plant receives over a full 24-hour period. And once you understand how to control it precisely, you can unlock higher potency, better structure, and significantly improved yields without increasing stress. Imagine consistently harvesting more potent, higher yielding plants simply by making smarter adjustments to your lighting schedule and intensity. That's exactly what we're breaking down today. How to tailor DLI to each growth stage, how to avoid the most common mistakes that cost growers potency and yield, and how to find the balance between maximum photosynthesis and unnecessary plant stress from seed all the way to harvest. Let's start by decoding what DLI actually is. Daily light. Integral is the cumulative amount of light photons a plant receives in a day, measured in moles of light per square meter per day. This is why hours of light alone isn't enough. Two plants can both receive 18 hours of light, but if one is under weak intensity and the other under strong intensity, their DLI, and therefore their growth potential, will be completely different. DLI accounts for both duration and intensity, which is why it's a far more accurate way to evaluate lighting effectiveness. This is also why more light isn't always better. Plants operate within a usable range, and once you exceed that range, you stop gaining efficiency and start accumulating stress. There's a Goldilocks zone for DLI at every stage of growth, and your job as a grower is to stay inside it. During the vegetative stage, the goal is structural development. You're building root, stems, leaf mass, and branching that will later support flower production. In this phase, plants respond extremely well to increasing DLI, but only up to a point. Too little light in growth is slow and stretchy. Too much light too early, and you'll see stress responses that actually limit development. Optimizing vegetative DLI means matching light delivery to plant size and genetic potential. Young plants don't need aggressive DLI, and pushing them too hard can cause leaf curl, slowed root growth, or reduced internodal spacing that limits airflow later. As plants mature, their DLI tolerance increases, and this is where you can gradually raise intensity to fuel rapid, healthy growth without overwhelming their photosynthetic machinery. When plants transition into flowering, DLI becomes even more critical. This is where many growers either leave yield on the table or unintentionally damage quality. The shift from vegetative to flowering lighting should be gradual. Sudden spikes in DLI can shock plants, disrupt hormonal signaling, and stall early flower development. As flowering progresses, the plant's demand for light increases, but so does its sensitivity to stress. This is where precision matters. Properly tuned DLI during mid-flower supports bud site development, biomass accumulation, and resin production. Push too hard without the right environmental support, and you'll see light bleaching, terpene degradation, or reduced cannabinoid expression. Late in flower, the balance becomes even more delicate. While it's tempting to push maximum light to squeeze out every last gram, exceeding the plant's photosynthetic capacity can actually reduce final quality. Cannabinoids and terpenes are secondary metabolites, and their production is tightly linked to plant stress levels. The goal is controlled optimization, not brute force. This brings us to the difference between productive stress and destructive stress. Plants have a saturation point for photosynthesis, where additional light no longer increases carbon fixation. Beyond that point, excess photons generate heat and oxidative stress without contributing to growth. Recognizing this saturation threshold is key to mastering DLI. High DLI environments also demand higher CO2 availability. Without sufficient CO2, plants become carbon limited, meaning they can't utilize the extra light efficiently. This is why increasing DLI without adjusting CO2, temperature, and humidity often backfires. Lighting never operates in isolation. It works as a part of a system. Environmental conditions play a massive role in how plants respond to DLI. Temperature influences enzyme activity, humidity affects transpiration and nutrient flow, and airflow prevents localized heat stress at the leaf surface. When these factors are aligned, plants can handle higher DLI safely and convert that light into growth and chemical production instead of stress responses. Looking ahead, advanced growers are beginning to move beyond static lighting schedules altogether. Smart controllers, automated dimming, and dynamic photoperiod adjustments allow DLI to be fine-tuned in real time based on plant development. Instead of running one intensity for weeks at a time, lighting can adapt as plants grow, flower, and mature. Another emerging concept is spectral DLI. Not all photons contribute equally to plant responses. While total DLI matters, the spectral composition of that light influences morphology, internodal spacing, terpene expression, and overall plant behavior. Understanding how different wavelengths contribute to effective DLI opens the door to even finer control. The future of optimized growing lies in predictive modeling. By tracking historical data, strain behavior, and environmental responses, growers can begin tailoring DLI strategies specific to individual genetics. This moves cultivation away from generic recommendations and toward truly precision-driven production. At the end of the day, mastering DLI isn't about blasting plants with as much light as possible. It's about delivering the right amount of usable light at the right time in the right environment. When you get that balance right, plants reward you with higher potency, better structure, improved yields, and more consistent results across every cycle. If this breakdown helped clarify how DLI actually works and how to apply it properly, make sure to like, subscribe, and drop a comment. And if you want deeper dives into advanced lighting strategies, environmental optimization, and real plant science, you're in the right place. Well, that concludes this video, guys. Again, thank you for watching, and I'll catch you on the next one. Peace.